Hi, everyone. Since it's a short talk, I'm going to try to be as quick as possible. We're going to be, I borrowed this image from Riot. I hope they don't get mad at me. We're going to be talking about cleaning tech debt and how to be technical about it. We're going to say categorizing it, what is technical debt, how to classify, some good practices, things to keep in mind, and that should wrap everything. So let's get started. First, a little bit about me. I have been developing software for around 15 years, give or take. I'm currently a manager at iOS engineering at the NFL in LA. And yeah, I have touched several technologies. They all have tech debt. I do believe code is art. That's why I put that there. I think we are all creative. We are not just like developers. And that's it. So what is tech debt? That's very hard to answer, and I know there's a lot of heated discussions online about this. I have read some posts on Medium. People really rage about this topic. But I'm not trying to say what's right, what's wrong. It's okay if you don't agree with something, but it's good to define what is tech debt, especially in your company, in your team, so you can actually work on it. And it's important to separate technical debt to dream goals, to architecture changes, so something you'd like to do with your app, but it's okay if you don't. So those are not tech debt. So I like to say debts are bugs in general. Anything is a bug, is user-facing or not, is a technical debt. You should probably fix it. So no documentation is a technical debt. You're making your code hard to read. Even if it's documentation in the code, that's fine. Super long classes, those are hard to read and understand as well. Unreadable code, of course. And architecture changes, let's say you're using massive view controllers and you want to go to model view, view model. I wouldn't say that's technical debt. That's something nice to do. Maybe you can get more organized, but it's not really a technical debt. Or maybe you want to use reactive programming, you want to use reactive Cocoa or something. It's also not a technical debt. And then I put two other examples like monolithic repo, database solutions. Just be aware of what you want to do with your app and what's the actual technical debt. A few more words on the topic, because I know it's hard to define, so from really important people right here. So Dan Radigan from Atlassian, he says that technical debt's the difference between what was promised and what was actually delivered. And I think that's a really good definition, because we all have a great idea in our minds when we want to work on a project, when we want to deliver it. We put everything in a paper, but when it gets time to build it, we don't have enough time, and then we deliver something different. And first law of programming says, technical debt includes those internal things that you choose not to do now, but which will impede future development if left undone. That's a very technical definition for technical debt. I like this one too, so I put it there. So now that we kind of know how to trace the line between technical debt and not technical debt, I think it's time to actually classify and prioritize. And that's the most important slide, because that's where we get technical. Because if you have an app, it's running for a year or 2 or 3, you probably have a lot of technical debt, and you need to prioritize where you want to go work next. Especially in your team, you got to make sure you communicate to your manager, to your whole team, hey, this is important. We need to fix it. So I like to classify this in 3 big columns. Oh, not columns, but I like to classify in 3 different categories. Like, you got to measure the impact of the technical debt, the cost to fix it, and the contagion. I'm going to go through all the points you can actually score technical debt. I also borrowed the main categories from Riot because I think they nailed. And so impact usually is the one that's going to determine urgency of your technical debt. If it's a bug, if it's a user-facing issue, something not working, you should top prioritize that one. And that one is not going to be hard to convince your manager to actually fix it. And maybe something internal, maybe something that slows down build processing time, build times, so developers are not working as fast as they could. It's not user-facing, it might be harder to communicate to your manager, but that's the impact, and I think it's also a huge impact. Cost to fix it. I'm sure we all used to Agile and creating tickets and ranking our tickets, might be in days or maybe Fibonacci scale. It's really important to measure how much time it will take to fix the technical debt. Because sometimes it's going to be something quick, and it's going to be easy to convince your manager to actually go work on it. And if it's something huge, can we split it up? Can we maybe divide in 2 separate sprints so you don't block like several days of several developer time to actually fix it? And the third category would be like contagion. And that, I think that a lot of people don't look at that when they are measuring a technical debt, but that's really important. If you have a well-contained technical debt, doesn't matter if you fix it today or a month from now, it's going to take the same amount of time. But let's say you have something in your code that is contagion, like all the developers in your team, they might copy and paste your code to use somewhere else. Now you have more debt. Or maybe you have a utility function and someone extend their utility on a string function or something, and now the whole team is using something that's slowing down your project. It's not what's wrong and you would like to fix. So contagion is really important. You influence whatever code you write on your repo, some other people will look at it and they might copy and paste. So even maybe if you don't have time to fix it, you can contain it. You can write a new layer of abstraction on top of whatever is wrong with your code, put in a separate class, write documentation about it so other developers don't copy and paste something that's wrong. And then I would rank these categories, like you give a 1 through 3 or 1 to 5 on each, and then you can actually prioritize them on your sprint. Then you can say, okay, this is a huge impact, not contagion, but we should fix because it's huge impact. Or maybe the cost to fix is very low and it's contagion, so another reason to prioritize that higher. And I think it also facilitates when you explain to your manager, to your team, why you want to fix that before some other thing. So at least you have documentation on your technical debt. And now you have it, so always log it. Always, whenever you see a technical debt, an error or something in your class or algorithm, always log it. Create a ticket, so at least you know it exists. Spread the word in your team so other people know that thing exists. Sometimes you have to create technical debt because you don't have enough time to put the right architecture in place or something like that. But at least if you document it, other people will find it. And then if you can get into the sprint and you can convince your team to work on it, perfect. Now it's time to fix it. And let's clean this technical debt. It's done? Are we done? Not yet. I think identify and classify and fixing technical debt is not the hardest part. Like preventing it's super important because if you can prevent the same mistake from happening again, you're just saving time, you're saving money. So never sweep technical debt under the rug. Here, just like some good practice to keep technical debt away. Never sweep technical debt under the rug. That means if you see it, log it. Create a ticket, put a ticket in Jira, or let your manager know, write in the code, whatever it takes, but let other people know that it exists. Methodology and process that help, as I said, creating tickets, that helps a lot. Automate bugs away. Let's say something on an algorithm, that's something that was a wrong calculation or something, write a test for it. If you can automate fixing it, you also like block other people from doing the same mistake, so you can write a test. Regression test continuously, that pretty much means the same thing, but you don't run them manually. You commit your code in repo, so Jenkins or whatever you use, Jarvis is gonna build, run your test, and fix it. Have a better rules for done inside sprints. I think that speaks a lot. Sometimes you get your code ready, and right after you commit, you check your ticket is done, and you move to the done column. But that's not the right approach, right? Because you might have some bugs or something in your code that hasn't been tested. So it's technically not done yet. So you can, if your company does that, like if they see code complete as done, you can actually take a step further and say, no, test complete and test pass, that's actually done. Always document, as I said several times. I mean, it's an iOS conference, Apple, so we all are on Xcode. We can use the to-do and the fix me on your code. There's actually a very useful script that you can turn those fix me and to-dos into warnings. So every time you build a project, you see a list of warnings, so you don't have to search for to-do anymore. I have some links on the last slide. You can grab that script and put in your project. I think it's a great thing to do. And that way you create a culture of quality in your company. Like if everyone knows the issues and the technical that you have to fix and how to prevent it in the future, I think that's a better path forward. Things to keep in mind. There's always going to be technical debt. That's not something you can get rid of completely. Oh, my company, my team's perfect. We're never going to create technical debt again. That's not possible. You're always going to find it, but you can find ways to have less technical debt. So you can do a little bit of upfront thinking. Let's say you're creating a new feature, you're creating a POC, and then, okay, your boss told you, create this POC, I want to test a strategy. You do it, but you know that after the POC is done, he's probably going to come back to you and say, okay, let's use this POC in production. We don't have time to build a proper architecture. Let's use this. This is working. Let's just put the right design around it, and let's use it in production. So if you know that's going to happen, you can do a little bit thinking upfront and isolate that code. Say, okay, this is not 100% clean code. I'm going to put this inside another class. I'm going to flag it as a POC, and if my boss wants me to use it later, at least it's clear the consequences. Isolate always when possible. I think that's super important. Old code's not technical debt. I put that there because I read somewhere, I heard a lot of people saying, oh, I need to touch code that some other team wrote 2 years ago and it's total garbage. Well, it could be total garbage, but it could also not be. Like I have seen a lot of libraries in C, C++, 10 years old, and they're clean code. They're documented, they're easy to follow. They might use old practice, but that doesn't mean there's old code, actually. Documentation is key, of course, and embrace it. You might have some technical debt, might be hard to explain to your manager, your team, but you need to accept it. Let's see what else I have here. Oh, avoid contagion. As I said on the third slide, the most important one, think about contagion. Contagion is very important. And I think that ends it. Please keep in touch. If you have any questions, I work at NFL. We have a team of engineers. We do have a lot of technical debt. I definitely have some stories to share. Hit me on GitHub or Twitter. I have some reference links there. I can put the presentation somewhere. I don't know. I kind of want to give you guys the link that has the script. If you guys want to use the to-do and fix me next code, turn those into warnings, please hit me up and I can share that with you. And thank you very much.